This is a tutorial about the periodic table and all of its parts. The elements are found on the periodic table. I like to abbreviate it as PT. The periodic table has columns going up and down, and it has rows going left and right. The rows that go left and right are horizontal. They're called periods. You can also call them rows. The groups, also known as families, also known as columns, are the vertical columns. They go up and down of elements. Elements that are in groups, also called families or columns, have similar chemical and physical properties. That's why they're called families. Just like you have similar properties as your family members, the elements in the same family have similar properties as well. Here's an example of a periodic table, and if you notice on the top here, there seems to be a numbering system. There's a few ways you can number the periodic table. As seen here, you can go from left to right and number them 1A, 2A, skip the middle part, and then continue on 3A, 4A, 5A, all the way to 8A. That's one way to number the periodic table. You can also number it by going all the way across and counting every single column. So this would be 1, this would be 2, 3, 4, 5, and all the way across until you reach 18. If you notice, there's a couple different color codings going on here on the periodic table. In gray are all the metals. In yellow are the nonmetals. Take note, there is one nonmetal over here, hydrogen, and the reason why hydrogen's there is because it has more similar properties as its column of metals than it does with the nonmetals. Also seen here in this aqua color are called the metalloids or the semimetals. They straddle a staircase. Let's see if I can kind of draw this in here. They're the elements that have both metallic and non-metallic properties. On the bottom are the lanthanides and actinides, and they actually belong in this group seen over here. If you actually insert them in, they will shift the entire periodic table over, and so they're put on the bottom. The elements that I circled here in the middle that go all the way from edge here to edge here are called the transitional metals. The transitional metals. There are different ways to classify our elements. Monatomic, diatomic, and polyatomic are some ways. Monatomic are elements that just exist as single atoms. They don't need to necessarily be with another atom, though most atoms like to bond. They can also be by themselves. So an example would be tin. Majority of our elements can and do have the ability to just be by themselves as elements. Then there are some elements that no matter what, they need to bond with something. There's 7 of them. These 7 elements cannot ever be by themselves. So they like to bond with any other element seen on the periodic table. Well, what happens when there is not another element to bond with? They bond with another one of themselves. So these 7 are seen here. Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. You need to memorize these 7. These 7 are called the diatomic elements or the diatomic molecules because if we have nitrogen seen here, nitrogen can't be by itself. It will automatically team up with another nitrogen and bond. Just like that. This is a diatomic, now it's called a diatomic molecule. 2 or more elements bonded together that are the same. Now, in order to help you memorize these 7, there's a funny little acronym called HANCOLBRIF. HANCOLBRIF stands for hydrogen, oxygen, nitrogen, chlorine, bromine, iodine, fluorine. Here are the 7 elements that can never be by themselves. I like to call them the loner elements. Then you have a classification called polyatomic, and these elements like to be in groups of 3 or more. So there aren't many of them. The example you need to know is phosphorus. Here's a pictorial representation of what we just talked about. So here would be an example of most of the elements. They can be by themselves. And when they are by themselves, if you notice this is neon gas, they don't connect with one another necessarily. Whereas in this example, here's one of the 7 diatomic molecules. Notice hydrogen has paired up with another hydrogen because it just can't be alone. And there was nothing else in the beaker to pair up with. And then here's the example of phosphorus bonding to 3 other things. Here's that main phosphorus binding to 1, 2, 3 other atoms of itself. Here's a quick review about the atom. The atom is made up of different parts. The 3 main parts of the atom are the electrons, the protons, and the neutrons. The protons and the neutrons are inside the nucleus. The nucleus is a very small, dense, tightly packed middle piece of the atom. Then outside is the electron cloud. The electron cloud has the electrons in it. The electron cloud is mostly made up of empty space, too. So the electron cloud is the big majority part of the atom, whereas the nucleus is the tiniest part of the atom. The protons, neutrons, and electrons are called the subatomic particles. Subatomic, sub meaning below, atomic means atoms. So within the atom, these are the particles. Remember, the protons are positive, the neutrons have no charge, and the electrons are negative.